Projects. In this video, we are going to explain about a project titled Integrating Stacked Sparse Autoencoder into Matrix Factorization for Rating Prediction. So now coming to the introduction part, by combining the power of SSAE with matrix factorization, the proposed approach aims to achieve better performance in predicting user item ratings, particularly in sparse and high-dimensional datasets. Through experiments and evaluations on real-world datasets, the effectiveness of the method has been demonstrated, showcasing its potential to enhance recommendation systems and provide more accurate and personalized rating predictions for users. Firstly, matrix factorization provides a principled way to model latent factors and discover latent features that explain the observed rating. Meanwhile, the SSAEs can efficiently learn non-linear representations of users and items, addressing the limitations of traditional linear factorization methods. So now coming to the objective part for this project, by combining the strengths of matrix factorizations and SSAEs, the proposed approach aims to achieve more accurate and personalized rating predictions for users, specifically in scenarios where data sparsity is a significant concern. The ultimate goal is to enhance recommendation systems by providing better and more precise suggestions to users, leading to improved user satisfaction and engagement with the platform. These representations are then decoded in subsequent layers to reconstruct the original data. During the training process, the model minimizes the reconstruction error, encouraging the SSAEs to learn discriminative features that enhance the understanding of user-item relationships. So now coming to the requirements part, we have two types of requirements, that are hardware requirement and software requirement. In hardware requirement, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDE, that is 3.7 version is required. Now coming to the methodology part, first upload movies dataset. The first step is to acquire and upload the movies dataset. This dataset typically contains information about users, movies, and corresponding ratings. Each row represents a user's rating for a specific movie, and the columns contain relevant attributes such as user's ID, movie's ID, and ratings. Second, pre-processed dataset. Before training the recommendation model, the dataset needs to be pre-processed to ensure its suitability for the chosen approach. Pre-processing involves tasks such as data cleaning, handling missing values, and converting categorical variables into numeric representation. Additionally, data normalization or scaling may be performed to bring all features to a comparable scale. Third, run SSAE recommendation model. The core of the process involves training the stacked sparse autoencoder, that is SSAE, recommendation model. This model combines the strengths of matrix factorization and SSAEs to capture latent features from the data effectively. During training, the SSAE learns to encode the raw user item interaction data into compact and dense representations through multiple layers. Fourth, run RMSE graph. After training the SSAE recommendation model, it is crucial to evaluate its performance. One common evaluation metric for rating prediction task is the root mean square error, that is RMSE. The RMSE measures the differences between the actual ratings and the predicted rating. To generate the RMSE graph, the model's prediction on the test set are compared against the ground truth ratings, and the RMSE is calculated for different approaches or iterations of the model during training. Fifth, predict rating. So in this predict rating, once the model is trained and its performance is evaluated, it can be used to predict ratings for new user movie pairs. Users can input their preferences for specific movies, and the model will generate predicted ratings based on the learned latent features and relationships. These predicted ratings can be then used to generate personalized movie recommendations for users. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder named as dataset. In this we are containing some dataset over here. And another folder named as model. In this we are containing .h5 files which contain the deep learning algorithms information. These.h5 files can be loaded into the project code during runtime to utilize the trained model for various tasks, such as making predictions on new data, performing specific operations. So here this is the main Python file and this is containing the Python script in it. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. So now click on upload movies dataset button to upload the dataset. Here I am selecting this dataset folder and now click on select folder button. So here on this screen we can see that the dataset loaded and we can see some values from dataset. And now click on pre-process dataset button to remove missing values and then build matrix vector which can be input to SSAE model. So here dataset cleaning process completed and we can see that dataset contains 10,000 records and application using 80% dataset size, that is 8,000 records for training and 20% that is 2,000 records for testing, and to calculate RMSE. So now dataset is ready and now click on run SSAE recommendation model button to build SSAE model. So here on this screen SSAE model generated and its RMSE error is 0.0062%, which is quite similar with paper. And so now click on run RMSE graph to get the graph. Here on this graph you can see that x-axis represents epochs or iterations and y-axis represents RMSE, and in this graph we can see that increasing epoch the RMSE values start from 3.0 and at 10 epochs it has to drop to 0.6. So now closing this graph, click on predict rating button to enter movie name ID and then SSAE will predict ratings for that movie ID. So here I am writing 157. And so now click on OK button over here. So here on this screen we got rating value as 3 for 157 movie ID and now test with other ID. So now again click on predict rating button and now here I am entering 1. Now click on OK button and so now here on this screen I give 1 as a movie ID and it is showing that SSAE will predict rating for that. Here the predicted rating is 5. Similarly, you can enter any movie ID and SS rating will predict ratings for that. So now, coming back to the conclusion part. In conclusion, integrating stacked sparse autoencoder into matrix factorization for rating prediction presents a promising and novel direction for improving recommendation systems. As research in this field continues, further advancements and refinements to the hybrid approach are expected to elevate the performance of recommender systems even further, leading to more accurate and efficient user items rating predictions and ultimately enhancing the overall user experience in various online platforms. The model's ability to learn non-linear representations of users and items contributes to more personalized and tailored recommendations, thus improving user satisfaction and engagement.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.